Okay, thank you very much, students. In this class, I'm going to talk about the generating function. Okay, right now look at that. If A0, A1, A2, AK are sequence of real numbers. Sequence of real numbers means all the numbers 1, 2, 3, 5, minus 10, 100, thousands like that. Then the infinite series g of x equals a naught plus a1 x plus dot 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 plus a k x power k plus dot dot dot. In short form, the summation of k tends to 0 to infinity a k x power k is called the generating function of the sequence. Generating function of the sequence a0, a1, a2, a3 dot dot dot, or shortly saying ak. What you understand, or what we understand, is that there is a sequence of numbers we are taking, and with that particular sequence of numbers, the first number is multiplied by x power 0, and second number is multiplied by x power 1, and third number is multiplied by x power 2, like that, and those are added, and we will get one function which involves x. Am I correct? That particular function is called generating function of this sequence. Very interesting. Am I correct? A1, A2 are real numbers. First number you are multiplying by x power 0 plus. Second number you are multiplying by x power 1 plus. Third number you are multiplying by x squared plus. Like that, it's going on. So this would be a function. Am I correct? And that function we are writing as g of x, and that's called generating function. Generating function. And short form is summation of k tends to 0 infinity, you will get this ak x power k, and this function is called generating function. Change the color, keep the color. Okay, let's cancel that. Now look at that, this expression 1 by 1 minus x, we know well 1 by x inverse is equal to 1 plus x squared plus dot 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 f of x. This also of this generating functional form. Am I correct? Look at that, 1 plus x squared. In this particular case, what is ak? Ak is nothing but 1, 1, 1, like that. Binomial series, now another example for this generating function, where ak is this, nck or this. Okay, nck, for different ck you will get different expansion, and that expansion is this. So another example for generating function is this. Now let us take some problems in generating functions. In generating functions we are going to take some problems. Okay, right. Suppose the sequence is ak, where each ak equals 3, you will get or we will get the sequence like this: 1, 3, 3, 3, 3, dot dot dot. Now what's the generating function of this sequence? What is the generation function of this sequence? Where ak equals 3, you will get 3, 3, 3. What I told just before, multiply this first number by x power 0, multiply the second number by x power 1, multiply third number by x power 2, and add all of them, and that is a function of x. That function is called a generating function of the sequence. That's what I told just before. So general form of the generating function is g of x equals summation of k tends to 0 ak x power k. This is the general form of the generating function. So in this particular case, what is ak? ak equals 3. So in the place of ak you put 3. This is constant. Sometimes not a constant, some other functions may be there. But in this particular case, what we see is k equals 3. That means 3, 3, 3. Therefore, ak we can replace by 3. So summation of k tends to 0 infinity 3 into x power k is the generating function of this particular sequence. Now other problem I am taking, the sequence I am taking as ak. Look at this. ak means k plus 1. That sequence I am taking here. Suppose a1, 1 plus 1. a2, 2 plus 1, 3. a4, 4 plus 1, 5. If that is the sequence defined like that, then what would be the generating function? What would be the generating function? Okay. The generating function, as I told you, is given by the formula summation of ak x power k. That's what? Generating function, g of x. So g of x equals summation k tends to 0 to infinity ak x power k. But here, how ak defined? How the sequence are defined? The sequence are defined like this. So in the place of ak, we are substituting this k plus 1 and this x power k comes as it is. As a result, you will get this is the corresponding generating function of the sequence. If you expand this, you will get this. When k is equal to 0, you will get 1 into x power k, 0, 1 you will get. If k is equal to 1, 1 plus 1, 2. You will get 2 here, x power 1. If you put k equals 2, 2 plus 1, 3. Then k is equal to 2. This term you will get plus 4 x power cube, like that, dot dot dot. Therefore, the exact generating function of the sequence is 1 plus 2x plus 3x square. Another example is this. This ak is a sequence for which what is a generating function? That's what we are interested in. Now look at that. This ak is defined like this. ak equals 2 per k. We know the general generating function is represented as g of f equals summation ak x per k. So the place of ak is substitute 2 per k. So 2 per k. For k is equal to 2 per k. For given, therefore we are substituting there. Now this is exact expansion. Okay. Look at that. When x is equal to 0, you will get 2 power 0 into x power 0, you will get 1. If x is equal to 1, you will get 2 power 1, x power 1. If you get x is equal to 2, you will get x power 2, x square, 4x square, like that, dot dot dot. Therefore, the generating function of this sequence is this. G of x is this, where x is a variable. Others are coefficients, constants. Very interesting, is that not? Now look at that. If 1, 1, 1 is the sequence, then what would be the generating function? First number multiplied by x power 0 plus second number 1 into x power 1 plus third number 1 into x power 2 plus fourth number x power 3 plus dot dot dot. In the short form, how can we write this? Summation of k tends to 0 to infinity ak x power k. What is ak? ak is 1, 1, 1, 1. Look at the last one. 1 a square, a cube. Multiply this by x power 0. Multiply this by x. Multiply this by x squared. Multiply this by x cube. You will get g of x is equal to 1 plus ax plus a square x square plus dot dot dot. We know that the short form of this is 1 minus ax inverse. So that is about the generating function of a given sequence. Very interesting. Thank you very much. In the next class, we'll be looking at the other topics. Okay. So goodbye. God bless you.